Okay, last example we did linear factors. We just have to modify our method just a little bit if we want to do repeated linear factors. And a repeated linear factor, that is basically, okay, like in the last one, where was it? Okay, here's the last one we did. I had two different factors. Okay, they were completely different from each other. Well, when they're the same factor, like when I factor out this one right here, we have to remember. Well, basically, so we've got two factors, so we'll have two terms here. But I need to make sure that the powers on these terms are ascending. Okay, I don't know why that is. I know how to do it. I think it's a little it's pretty theoretical. Maybe I'll figure it out one day, but. The important thing to know is just basically this formula. I don't know if you can see that, but these are just 1, 2, C would be 3, and so on and so on. So right here, this polynomial, we got two factors. So, the first one is just going to be regular, the second one would be squared. Had there been a third factor, yeah, we'd have an x minus 1 cubed, okay? So, basically that's where we're gonna go with that. So I just rewrote it up here, and let's go ahead and we'll just knock this one out. And it's not gonna be too bad at all. It's even gonna be easier than the other one. So all I gotta do is all I have to do to get a common denominator is I just gotta multiply in the one term. Okay, and like I said, that's where things get icky. So, alright, now that we do have the common denominator, I don't even have to worry about it anymore. Okay, so we can just go 2x plus 2 and ax minus a plus b. Okay, and I mean that works out just perfect because I only have one x term. Okay, so a is worth 2. And then negative a plus b is also worth 2. Okay, so negative 2 plus b is equal to 2. We add the 2 to both sides. B is equal to 4. Okay, so going back here, we could just say a was 2. We get 2 and 4. Okay, and now it's pretty easy. I mean, really, with these linear factors, they are pretty easy. Okay, they're really not going to be too bad. Okay, but trust me, once we get a little further in the quadratic ones, I mean, you'll see what I'm talking about. Okay, but just keep on, get these concepts down, and everything. It'll definitely help you later on. Okay, see, here's another one. Okay, I started, while I was talking. So, I mean, basically, we have the same thing. We just got to remember, hey, we got a square term right there. Okay, so, again, let me grab another color. And let's see here. So, this x plus 4 will be equal to... Well, that'll just be, I'm not even going to be rigorous about it. Okay, I kind of wish I had picked a tougher example, but, hey, such is life, right? And a plus b is equal to 4. So, we got 1 plus b equals 4. Okay, so definitely looks like b in this case is equal to 3. So the decomposition on here would be 1 over x plus 1 plus 3 over 2, or what, squared. Okay, so you know, I think as far as linear factors go, you know, you can see it's really not too bad. And I mean, it'd probably be a little more complicated. Had I really thought it out, I probably would have picked one that had 3 factors in there. I made one up a minute ago, but it turns out, like, when I solved the system of equations, it was just crazy. You know, I didn't get a nice number, so you know, these ones I was able to kind of make them up a little better. So you know, that's pretty much, you know, it for the linear factors. And like I said, those are the easy ones, okay, and they're really no problem. I mean, you know, they're pretty simple, as you can see. You know, just remember, you know, when you set it up and decompose them, you know, the powers on your corresponding terms need to be ascending. I mean, they keep going up. Okay, so let me see if I can't put together some examples of you know, like maybe a situation where, you know, we have a polynomial that doesn't factor at all, or something like that. Okay, and because those will definitely take a long time. Okay, thanks for watching.